We're going to solve weekly contest 60 today. There are 4 problems, so let's start with plot fill. In this problem we are given an image grid, a source row, source column and a color. We need to perform plot fill on the grid and return the modified image grid. They are giving the definition of plot fill, that is, to perform plot fill, consider the starting pixel plus any pixel connected 4 directionally to the starting pixel of the same color as the starting pixel plus any pixel connected 4 directionally to those pixels and so on. Replace the color of all of the aforementioned pixel with color. Return the modified image after performing the plot fill. So let's consider the first example. In the first example we can see we have an image grid and a source row and a source column and a color. We need to modify the grid in such a way that all the pixel connected to our source pixel 4 directionally having the same value of our source pixel need to be modified with the given color. You can use depth first search or breadth first search to solve this problem. I'm gonna demonstrate the depth first search approach here. You can find the breadth first search approach in source code in the video description. So this red pixel is our source pixel. We have 4 pixels connected to this red pixel in 4 direction. Among them these two have the same value as our source pixel, so we're going to consider these two. So let's consider the top one first. Before consider the top one, we need to change the value of our source pixel, that is going to be the color that is given to us. And then as we are considering the top pixel, so we're going to change the color of this pixel as well. Now let's consider the top pixel and have the 4 directions that are connected to this are these 4. Among these 4 this one is out of bounds, so we won't going to consider this. This one is where we are coming from, so we won't going to consider this. We are going to consider the right one and the left one. So let's consider the right one first. And the right one have 4 pixels connected to this one, that are these 4, but among them this one is out of bounds, so we won't going to consider this. This is also out of bounds, we won't going to consider this. This is 0, not having the same value as our source, so we won't going to consider this. The only pixel that we can consider is this one, but this is already checked and changed to our given color, so we won't going to consider this as well. Now let's go to the left one. So left one has 4 pixels connected to this, and among them this is out of bounds, so we won't going to consider this. This is out of bounds, we won't going to consider this. This is where we are coming from, so we won't going to consider this. This is the only pixel that we're going to consider. So before checking the right one, we obviously change the value of this left one as we consider this. So this is 2, and as we consider this left one, so we also change the value of this to 2. So after that we only need to change this one's value because other 3 are not going to consider, so this one have to be 2. So after checking this one have 4 pixels connected to this, that are these 4. Among them we are not going to consider these or this because these are already visited by us, and only pixel that need to be considered is this one. So we need to change this one to 2, and then check all the 4 pixels connected to this one, that are these 4, and all of them having the same none of them having the value of our source pixel, so this is the finishing point. But as you can see, we only consider this red block, not this red block. So after finishing this, we're gonna backtrack from this to this, this to this, this to this, and from this to this, and from there we're gonna see that we have one unvisited place, that is this one, but this is already visited by another pixel, so we don't need to consider this as well. So the values will be changed in such a way that we will get this output. Now let's code this up. Here first let's take the row and the column length. The row length is length of the image grid, and the column length is the length of the image grid first item, or we can say the image grid first row. We need to take the source value, that is our image srsc value. We also need a visit set to keep track of our visited pixels, and we need a direction array to get the 4 directions, so that we can easily manipulate the 4 directions using a for loop. Those are going to be 1 0, minus 1 0, 0 1, 0 minus 1. Okay, now let's define our depth first search function. Our depth first search function will take the row and the column, and it will first check if the row is out of bound, or the column is out of bound, or the row column is already in our visit set, or here we are keeping the row column as a tuple in our visit set, or the value of our current pixel is not same to our source pixel. So we can check that by using image rc not equal to our source value. So if that is the case, then we can just return, because we don't need to change anything. If that is not the case, then we're gonna add this value to our visit set as a tuple. Then we're gonna change the color of this image pixel. That's gonna be rc to the given color, and then we're gonna call the 4 direction that are 4 directionally connected pixels. We can call those by using a for loop for direction row and direction column in direction array. We can calculate the near row and near column, that is direction row plus row and direction column plus column. Now we can call this near row near column. Now we can call DFS on this near row near column, which will handle all the 4 direction connected pixels. Then we can just remove the row and column from our visit set, as it is not being visited anymore. This is our function. Then we can just call DFS on our source row source column and return the image. Let's see if this works or not. Yes, it is working. So let's submit and see if it is accepted or not. Yeah, it is accepted, and we can see that it is passing all the tests. So this is it for flood fill.